Alright, these will be target 6C notes. Interpret key features of graphs and tables. So this shouldn't be too hard. We all know how to read a table by now. We're just going to make sense of the relationship between the time and, in this case, the score in a test. So basically they're taking a test, an IQ test, and their score is getting closer to the lower intelligence intervals. Alright, so let's just look at the graph. It starts at 0, it goes to 10, to 20, to 30, to 40, to 50, to 60. And it starts at 85, and it's going down each time. So as we can tell, it's going down 7 each time. These are going up 10. So what is the relationship between the time and the score? We should notice that as time increases, the score goes down or decreases. So here we have to find out the score after 62 days. So you can tell they're going down 10, or I'm sorry, it's going up 10. We only want to go up 2, so we have to actually find the rate of change. So if we call this x1 and this x2, y1, y2. So as we can see, y2 minus y1, we're using this formula. Ten minus 0. Just plug those in. We get negative 7 over 10. This equals negative 0.7. This is how it's changing per day. It's decreasing 0.7 per day. So at 61, 62, we'll do it per day so we know after 2 days what this is. So 43 minus 0.7 is 42.3. And we subtract 0.7 from this again. You should have your calculators. 41.6. So the answer, the score after 62 days is 41.6. 62 days. That's it. Same with this one. What do you notice about the time and the amount of gas? Time increases. Gas decreases. Now we want to know after 73 minutes. So you'll find 71, 72, 73. So if we call this x1, x2, y1, y2, we have 22.5 minus 25, 10 minus 0. So it's 2.5. This equals 0.25. It's going down per day or per minute. So all we're going to do is subtract 0.25 from each of these. 71, it'll be 7.25. 72, it'll be 7. And here it'll be 6.75. So the answer is 6.75 gallons after 73 minutes. Alright. next part is actually just reading the graph and understanding the scenario. So here, this graph shows the distance from a practice field as you go home after practice. You receive a ride from a friend back to his house where you ate dinner and then you walked home. So this is just saying this is the practice field and this is the distance you actually travel in this amount of time. So we think at point A, what happened? Point A is actually just riding to your friend's house. Okay, this is the journey to your friend's house. Now here it gets flat, which means from B means you arrive at your friend's house. Now, if you remember the scenario, you ate dinner. So you received a ride, you got back to his house, and then you ate dinner, which makes sense. You got there, you ate dinner, you can tell what happens here. So at C, this means you ate dinner. And D, you can see what's happening then. You must be walking home from then. This graph just took this paragraph and actually just broke it down from riding your friend's house, getting there, eating dinner, and then you walk home. Notice how this one is steeper than this. You obviously don't walk as fast as a car. Be kind of cool if you did though. Alright, same things, you're walking home, or you're walking somewhere, you went to the store before shopping, play video games at a friend's house, and then walked home from there. So you should be able to piece this together the same way. So point A would be when you're walking to the store. Then you're in the store from here to here. After you leave the store, you walk to a friend's house, you hang out there and nerd out and play video games for an hour. Then you walk home. So you could fill this out basically using this exact scenario. 7. We just have to be able to tell the relationship between days and the tickets sold in the graph and table below. So here you're going to compare what's happening, the days for these. So this one's steady, the days are increasing, and that's affecting our other variable, which is tickets sold. Now, if we look at these, first day, a lot of tickets sold are early on, then it decreases, and then it jumps up again. So the days always increase. The tickets go down, then they go up. And here, it's not an exact constant decline, like this was a constant increase. So here, but the days still go up, and then the tickets go down. So if we look here, the days are always increasing. Here, after the first day was 60, so it went down, and it went down, and then it went up. So here, it went down to 65, which is only 5. Then it went down 15, and then it went down 5 again. So here was 5, here was 15, and here was 5. Whereas here was 15, 5, then up 35. And in F, these, day 1, 35, this one up the exact same amount. So if you had to guess which graph these belong to, this one steadily increased. That would be the graph of this if we had aligned the table with the graph. This one, it went down a lot, and then a little, and then jumped up. Went down, down a little more, and then went up. This one would go here. And this one would have to, which should make sense. 70, 65, a bigger drop, and then another same drop. These are the same drop. This would go here. This is all target C is, which is interpret key features of graphs and tables. Copy this down and do the practice problems. Peace.